Hello and welcome to this evening's TI Technology webinar hosted by Texas Instruments, where tonight we'll take a look at how TI-Nspire technology can engage your students in algebraic reasoning. I see that many of you are joining us for the first time, so we'd like to offer a special welcome if this is your first T-Cubed Professional Development webinar. We'd also like to thank everyone for completing the live survey on the right side of your screen. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. I'm very happy to introduce our two panelists tonight, Audrey Cucci and Matt Rhodes. Audrey is a T-Cubed regional instructor and mathematics educator for a public school in New York. She has taught a wide range of courses, everything from 8th grade to AP Calculus. In 2010, Audrey was recognized by the National School Board Association as a 20 to watch educator for her work with educational technology, namely the use of TI-Nspire and TI-Nspire Navigator in her courses. She loves having the opportunity to educate not only children, but educators as well. Thanks for being with us, Audrey.
Thanks for having me.
And after spending 16 years in the mathematics classroom, Matt recently accepted a position as an assistant principal at Sisterville High School near Charleston, West Virginia. Though he's taught all levels of secondary courses, he specialized in geometry, where he worked to develop new classroom strategies and activities designed to promote student achievement. As a member of Texas Instruments pilot program and T-Cubed regional instructor, he enjoys working to help other teachers find ways to integrate education technology into their own classrooms. Thanks for being with us, Matt.
Good to be here. Looking forward to a great session this evening.
We're expecting a large crowd, so your audio is muted. Feel free to send questions to all panelists using the Q&A window on the right side of your screen. We'll also send general messages in the chat window. Once we move to the teacher software, that right section of your screen will be replaced with a green floating toolbar. You can access the Q&A window by clicking the question icon. This session is being recorded, and as a reminder, we'll provide a link to the event certificate of attendance at the conclusion of the event. Once that recording is available, if you'd like to follow along with your handheld or your software, and we truly hope you will, we do recommend doing this with the recording. That way you can download the activities and then pause and rewind the recording as necessary. We don't expect you'll have any audio issues tonight, but in the event that you do, try selecting Communicate in the WebEx menu, choose Audio Broadcast, and then click Join. At this point, Matt is going to discuss our agenda.
Hello, everybody. This evening, we have some great stuff lined up for you. Obviously, Mike's taking care of the welcome and introductions at this point. But what I'd like you to go ahead and do is start filling up the chat window with your ideas on what is algebraic reasoning. I mean, as part of the practices for mathematics through Common Core, we've been thinking about algebraic reasoning for several years now. But many of us, and I'll be honest, myself included, have never really sat down to consider what we hold to be algebraic reasoning in our classrooms. So if you would, in the chat window, go ahead and start talking it up. Submit some ideas or I guess some definitions or some phrases that would describe how you talk about algebraic reasoning. Activities, lines of fit. That's going to be our first one, and modeling of quadratic functions. Those are the two that were advertised, and then Audrey and I would also like to have you all take a look at the characteristics of exponential functions and applications of function compositions. And then finally, we'll finish with some free online resources.
Thanks, Matt. And Audrey is going to discuss our expected outcomes.
Okay, so what we're hoping that you all leave with today, we're going to learn how the TI-Nspire technology and Math-inspired lessons can enhance students' algebraic reasoning skills. So again, there's that key phrase there, algebraic reasoning. We really do want to think about that in depth this evening. Second thing we want to be able to do is explore techniques for helping students interpret the linear model in the context of data. We're going to extend students' algebraic reasoning skills by using quadratic function to model a flight path of a basketball. That's your quadratic modeling. And then lastly, we're going to make sure that we stay in touch with the social media that we have available to us, as well as upcoming events. If you do utilize Twitter, you can use hashtag T3PD tonight and feel free to tweet away, and I'll be really excited to read those tweets once the session's over.
Thanks, Audrey. And Audrey, it is all yours.
Okay. Okay, so like we were talking about earlier, we really want to stress this algebraic reasoning and what it means to us as educators. And similar to Matt, when we were speaking on the phone about this session and what algebraic reasoning meant to us, it kind of occurred to us that we really hadn't done any real in-depth thinking about it, even though we've been teaching it for years and years. So we really wanted to get an idea of what other teachers, what you guys feel algebraic reasoning means in your own classroom or in your teaching methods. So does anybody have anything for us that they would like to share? And Matt, I can't see that chat window, so if you can pull anything, that'd be awesome.
I'm working on it right now for you.
Okay. So what I kind of started to think about was the patterns that we're looking for our students to kind of analyze and recognize, and then creating generalizations about those patterns. And I felt that that really kind of accentuated algebraic reasoning for me, because we're always looking for students to see in a different way, see it, you know, as something reoccurring, and how can they use what they see in one example and something that they're going to see later on. So algebraic reasoning for me really came down to being able to utilize the skills they learn at one time in a totally different realm. Matt, what do you think?
I am almost painfully a pure mathematician, and because of that, my definition would be algebraic reasoning is the relationship of numbers under a given rule, and then beyond that, starting to look at all the properties that would entail. And I'm loving what you all are saying in the chat window. From Reshmi, the way students interpret a real-world problem and use algebra to find a solution, and then making sense of algebra through multiple representations. It's wonderful because we're getting all these new ideas, and what we've come to realize is that oftentimes algebraic reasoning is described using the mathematical practices, about describing and looking at connections and repeated reasoning. And if you look down through the chat window, even as you all are typing in these responses, we're seeing those mathematical practices in action. So they tend to work hand in hand, algebraic relationships and the practices work together. So
we often see that students come up with these answers to these application problems, and they're so completely off the wall. And asking our students to really think, are your solutions realistic? Are they appropriate? That really is algebraic reasoning. It makes them really think about, does it make sense? And sometimes it doesn't, and they have to really work through that. So that it's a nice piece that we're really getting into this evening is, are our solutions reasonable? Are we ready to start with the lines of fit, Matt?
I do believe we are.
Okay. All right, so you're going to introduce this one?
Yes, ma'am. The lines of fit activity itself is very basic. If you would jump over to page 1.2 for me. looking at this, intuitively, it makes sense. We're going to try and drag that line as a best fit representation of the information. And at first glance, you think, sure, that's all fine and good. But then, as Audrey's doing, when you start to move that line, you begin to see some of the dynamic power of this. By moving the line, you're seeing the slope changing, you're seeing the y-intercept changing, and then the entire depth of this activity comes into play. Now, this needs to be mentioned that this is a middle grades activity. On the website, you're going to find this under middle grades. However, the quality of thinking as you go down through this can easily be brought into the high school classroom. Math 1, Math 2 could make good use of this because it goes into a very deep level of questioning. So looking at this is all fine and good, but when we start talking about the context of the problem, it becomes even richer. Notice the labels that are on the axes, math and verbal. The data that we're looking at is a correlation of the SAT scores that the states put out for this given year. This is the average verbal for the state versus its math score for the state. So this is real-life data. We're not just talking about made-up points in this. So just in and of itself, the activity is really good, and the students are able to see things. So if the teacher wanted to just be able to do a quick discussion of line of best fit to help people remember, that's all fine and good. Audrey, can you go over to the teacher notes for this? The part that I really want to focus on in this activity is how well it develops itself. I'm going to talk very briefly about the activity itself, and if you are a new teacher or first year, second year teacher, and you're still trying to deepen your understanding of what students need for lines of best fit, this is a great activity for you. And even your veteran teachers. When I looked through this activity for the first time several years back, it really spurred my interest in deepening my own understanding, and it really rejuvenated a lot of stuff. Now, the reason is because it does such a good job of walking through using both layman's terms and then this rich contextual understanding from mathematics. For instance, would you mind going down to question number 3, part B? So what we've got going on, the students are developing their own equations for this. And in part B, things like compare your equation to your partner's equation. Not only are we going through the mathematics, but now we're jumping straight into those mathematical practices. We're going to have collaboration between students. They're going to have to defend their equation, and then they're going to have to critique the equations of others. So we're going right through these mathematical practices just like we were hoping we were going to be. And the activity does a great job of scaffolding through these practices and developing the ideas that we need. We're talking about intersection, we're talking about slope, and it brings out all of these really great ideas. And there's also rooms for extension. Can you slide on down? You're going to see an Nspire nav right there. The Nspire Navigator opportunity. If you are a Navigator user, if you happen to have one in your classroom, this is a great place where you can do some screen captures. The activity prompts you when those good points would come up. And if you don't have Navigator, no problem. Just use it as the same prompt. Have the students share out their equations, and that way you can start discussing the nuances of lines of best fit. Mostly that it's a trial and error analysis. There's going to be some human parts to this where the slope isn't going to be exactly the same because one student's best fit won't necessarily be best fit for the other student. So we have a bit of productive discourse going on here. And notice the teacher tip below it gives you some more good ideas as you're going on. So the activity itself does a really good job of deeply going into this idea and helping them to start not just have the graphical understanding. Yeah, it should be through the middle. That's great. But where is that algebraic analysis, the algebraic reasoning between the graphical representation and the algebraic representation, the equations, and how are we making those connections and why do they make it work? This is a great activity to make those connections between the graphical and equation representations. Let's go over to the assessment piece. Oh, go ahead.
This question real quick.
Okay, no problem.
In this document says, would you want to use the line of fit or its equation to predict the math scores for a verbal score of 900? Explain your reasoning. So when we were talking about this, the kids really have to understand what's being asked of them. SAT scores only go between 200 and 800. So when you get a score of 900, the students have to know that it's not a reasonable solution. So that goes back to our students understanding, are your solutions realistic? Are they appropriate? So I don't want to say it's trying to trick them. It's trying to force them into thinking about whether or not what the answers they're getting are appropriate. So I really liked this piece of it, and it walks them through and it discusses, you know, some kids are going to say, yeah, it's great, we could totally get 900s, and others are going to say, oh, wait a second, we need to take a step back. So it's a nice extension piece for sure.
Yeah, I see students diving right into the sucker punch question and their line of regression and doing some great mathematics and finding the wrong answer. And it just opens up a great discussion. If you don't mind, I was going to jump over to the chat board real quick. I'm so excited to see the high school teachers weighing in on this activity. I'm seeing comments on Algebra 1, Algebra 2, chemistry, physics. There's so many great extensions to this for basic understanding of these topics. Excuse me. So, all right, can we go over to the assessment piece on this one? Now, this is a great activity in and of itself, but the really nice part about this activity is the assessment piece that comes with it. I'm going to venture to say all of the Texas Instruments activities have some form of formative assessment at the end, but this has a really dynamic assessment piece that goes with it, which could be a lesson closer. It could be your bell ringer as the students go out the door. It could also be a very nice next day trigger for previous learning. Did your students understand? And if you, again, I'm going back to the Navigator, if you have the Navigator, you can get real live data and have a pulse of your classroom, whether or not you need to go back and hit some points or you can move forward. But question 1, what is the best fit line? All we're going to be doing is moving it here, and it just gives basic instructions. So we're going to be moving it and then answering question up, down, increase the slope, decrease the slope. So that's a low depth of knowledge question, just engaging the question. And the other nice part about this, it is a file where the students are able to self-check. For those of you that haven't been able to use that property before in an activity, the students are able to know whether or not they're correct when they're on their handhelds. So we'll come back to that. And Audrey, can you help me remember that?
Yes.
Okay. The next one, select the line that fits best. So we're not just going to move it. They give us some options, and we need to pick which one's best, A, B, C, or D. Notice the nice color coding between the graph and your multiple choice responses. So we're getting a little bit higher. We're given options this time and which one is going to work. And, of course, I think the natural extension on this would be why does it work better than the others? And were you going to check the question properties there?
No, it was an accident. Sorry. I'm purposely not picking all of the correct answers, so when we do go and show you how we can utilize this file, you'll see that.
All right, and then over to 3.1. 3.1 is significantly stronger because we're not just moving lines. Now we've crossed into a different area we're now into the algebraic. We're not strictly on graphical representation. We're now doing that multiple representation. And you have choices. The student can pick their own adventure here. If they want to, they can draw a best fit line, analyze it, find the equation, and find which one matches most closely. Or, Audrey, what was the suggestion you had on this one?
Well, they could come over to this side of the screen and bring up their function bar and then actually type in the equation and attempt to graph it to see what it looks like. And you know, they may try all of them, and that's completely okay. If they put in 20, they're going to see, oh, wait a second, that doesn't look quite right. So it allows them a visual understanding of what those equations mean in relation to the data.
And you can also see some discussions here. If you notice, the scale of 4 is left on the graph, which means that we're basically looking at a square graphing screen here, and we don't have to worry about skewing the slope. So we can start talking about, well, do we think the slope is going to be greater than or less than 1? And we can start to have those discussions too. So the student has lots of options as to how they want to utilize technology in this to be able to get their answer. And then finally over to 4.1, write a line that fits the data. This is up to them. They're not given any guidance as to where they want to be, but like Audrey's showing here, as you type it in, your equation is going to come up and you can continue to tweak, if you allow me there, to tweak that and move it to where you want it to be. So students can play around and then finally get what they want. Now, some technical conversation here. After talking with Audrey extensively about this part of it, I really think that this is a technology-driven section. A lot of Texas Instruments materials can be done in a low-tech environment, just pencil and paper. But I think this activity, this assessment piece, is really driven by the Nspire technology. And it would almost require the students to have the Nspires in their hand, a class set, or on the iPads or something, because it would be very difficult to only do this through the screen. And for the Navigator users, and those that were mentioning, I have no idea what I did before a Navigator, I completely agree with you. The Navigator would allow you to easily send these out as quick polls. You can do them one at a time. Or you can use it as an assessment piece and send it out and grade it, because you'll be able to see who got the correct answers, who didn't, those types of ideas. So it is a technologically driven piece. And Audrey, did you want to show what the handheld looks like at this point?
Yeah, so this is a self-check document, which means the students, as they're doing this, can have instant feedback on whether or not they've gotten these questions correct or incorrect. Now, this can be done in the software by selecting menu and then check answers. And it's going to prompt you and say you're correct versus incorrect. I did select the wrong answer here somewhere, so menu. Oops. Sorry about that, guys. I'm on the wrong side of the screen. Menu, check answers, and it's going to tell me, oh, look at, I'm a math teacher, so my brain automatically clicks the correct one. My apologies. So it's going to tell you correct versus incorrect with all of these, which is great. Now, if your students have handhelds in the classroom, this is even better. So what I did is I used my software, and I actually went and logged in with my calculator. I'm hooked up to my computer. And what you guys are seeing is my handheld. So as I go through this, and I've answered most of my questions, I left this one blank on purpose. What the students can do now is they can actually use their thumbnail to do a quick check on whether or not they've gotten these correct versus incorrect. So on your handheld, you click Control, and as you can see, my buttons are turning red as I click them, and then up, and it's going to give me my thumbnail. The green check mark means I've gotten it correct. Awesome. So that's a real quick visualization. I can move on to the next one. On problem 2, the red X means I've gotten it wrong. I need to go back and relearn. Problem 3, there's an open circle, which means I have not attempted it. And then problem 4, another green check, and I've gotten that one right. So that's a very nice way, if you do send this home with kids as a quick assessment, if you do it at the beginning of class just for a quick review, that's a nice way for kids to check themselves.
And before we move on from, it's okay. From problem 4, because the students are required to come up with their own equation, even if they're very close, it may or may not give them credit for it. So just a heads up that you might run into some students that are frustrated that they thought they had question 4 right, but the software isn't giving them credit for it.
Right. Good. Okay, so is there anything else we need to talk about with lines that matter? I think we covered everything here.
I think we're in good shape.
All right, awesome. So let's talk about modeling with a quadratic then. So modeling with a quadratic is basically a one-page file, and what you're asking your students to do is you're asking them to come up with a path from when the ball leaves the shooter's hand until it meets the basket. So you're looking for a quadratic representation of that path. You have to pay attention. At the very bottom it says 2 tick marks equals 1 meter, so a lot of kids will be thrown for a loop if they don't pay attention to that little statement down there. When I first looked at this file, I had my Algebra 2 kids in mind because, you know, we talk about vertex form and how you can take the vertex and then talk about your coefficient of A, and so that was really what kind of jump-started me. However, it's also a great file for our younger kids, our 9th grade kids that are just kind of starting off with quadratics. With this lesson in particular, I really do suggest giving them the student document that goes along with it. So I'm going to show you that student document. I believe this is it. Okay, this is the student document. And the reason I say to give them this is because it really steps them through all different kinds of questions that go along with it. So we're looking for that path. There's a whole bunch of different ways that we can do this. The first thing that I think my kids would try as soon as they got this in their hand is they're going to say, all right, I'm going to take and I'm going to do x squared, and because I already know how, I'm going to take and I'm going to transform this graph and I'm going to move it around until it fits exactly the way I want it to fit. That's what my 9th graders are going to do. As soon as I give them the file, they're not even going to wait for me to give them the paper. They will have this done by the time I'm passing out papers. Done. With my Algebra 2 kids, I'm not going to necessarily allow them to do that. We're going to say, okay, let's figure out where this point right here is. Let's talk about the vertex. How can I use the vertex and the spread to determine the equation? But the transformation piece is great. What I really like about this is it's in vertex form. How often do we graph a parabola on a calculator and see the equation in vertex form? Now that we're talking about things like completing the square, it really becomes crucial that they're comfortable with this format. Matt, what do you think?
Oh, absolutely. So often you are seeing the x squared plus or minus x plus the constant, and it just doesn't have value in a situation like this. For this context, for your Math 1, Math 2 courses, depending on where your school is going to put that, you're going to see a lot more value coming out of this form so that they know what the numbers are doing.
Right. I think the best part about this whole file is the extension problems that you can kind of build off of this. The idea for me was after they've seen one of these, the kids are excited because they see a picture on the calculator. So the next thing they want to do is they want to go out and take pictures and put them on their calculator. So I jump on that and say, okay, you know what? Grab your cell phones, grab the iPads, let's go out. I want you to walk around the school and I want you to find a picture of something that is parabolic. Let's go get those pictures. Let's put them into a TNS file, and then you can give them to somebody else in the class, and they can determine your parabolic path. So it becomes like a little project that the kids get really excited about because it's real-life application, and that's the key. It's no longer just a parabola that, okay, great, it's a parabola. It's a parabolic path that represents something that they can see, that they can touch. So that, for me, is what is really striking about this lesson. It's a motivational piece more than it is anything else, and 90% of the time, that's your biggest battle, is getting them motivated in the material, and this does that.
Not only does it get them into the material, but it also does a great job of that algebraic reasoning, the connection between what's happening and the equations. Where will we see the vertex, and what does the vertex mean in this case? What do the zeros mean? And give it some real-life context.
Yeah, the zeros actually bring up a really interesting conversation, because the students will, when we talk about things in terms of time, that conversation always comes up about negative time. So to have that conversation and why the y-intercept is starting at, it looks like about 2 tick marks is 1 meter, so, you know, 1.5 meters. Why is it starting there versus at 0? Well, most of us have height, so you really do start having those conversations. And it's a nice conversation starter, and the kids, they do get into it, which is, it's nice to see. How are we doing? Everybody?
I think we're doing well. The one thing that I want to mention quickly, Audrey already mentioned it, but notice down there at the bottom, 2 tick marks equals 1 meter. You really need to take caution if you try to trace this. And you get values for your x-axis, for your vertex or whatever. Be very careful, because every 2 tick marks is 1 meter. So you basically have to cut everything in half to get your numbers. So just a word of warning there. I think we're good for that one. What do you think, Audrey?
It's a quick lesson. I think we should go on to characteristics of exponential functions, unless anybody has any pressing questions about it.
All right. Yeah, that's such a great activity, because it can go from anywhere in middle school into lower high school, all the way up through and including pre-cal, trig, and calculus, just to help them remember some of the basics. It's just a great activity. You will go on to the characteristics of exponential functions. All right. I'll have to be honest. This is a bit of, I don't know, I'm taking my own crusade here. I feel very strongly about helping students understand the algebraic characteristics of a graph. And this one, the reason I'm bringing it in is because of the earlier use of exponential functions in the core curriculum. That used to be an Algebra 2 topic, but a lot of Algebra 2 teachers didn't even get to it. It wasn't introduced until pre-calculus. And at that point, students didn't have a firm understanding of the reason why it's produced and the reason, actually, why it was moved down to Math 1. But this is an excellent activity, because it takes what is a very basic function, it's just the exponential function, and helps the students understand why it is that it has the shape it does. It's a very unique shape in terms of the family functions, but there's reasons why it does that. The simple fact that we're doing some constant b raised to the x value, or exponent, will take care of the shape. Can you head over to the next page? Now, all this does is change the base value. Audrey, can you grab that slider up there? So what the activity basically has them do is move the slider. This is a very direct action-consequence file, meaning the students do something very, very easy, and the file does everything that it's supposed to. Because all we're looking to do here is compare what happens as x increases from 1 to 10. Notice it stops at 1, and I think we understand why, that if you go below 1, all kinds of things go screwy. But they're just looking for repeated reasoning. Remember, that algebraic reasoning often goes through the mathematical practices. So in this case, we're looking at all these different situations, trying to find what is the same and what is different. So as b increases, what happens to the shape of the graph? Well, of course, it becomes steeper. And that's what every student is going to answer first. When they first see this, oh, it gets steeper. Not quite. And we really dive into it a lot more. The student activity does a great job of helping the students start seeing the ideas they need. When I do this activity, I don't let them just go through it. Audrey, what do you think about that?
Well, why don't we pull open that student document and take a peek at it?
This is one where I don't necessarily know that the students immediately see the connection, and I like to slow them down through this activity so that we can have a better understanding of what's going on, and then as you get toward the end, they start to be able to move faster. So just some really basic ideas here. Describe the characteristics. And then part B, grab and move to a larger value of B. What happens? Do any of the characteristics you described stay the same? What changes? So we're looking for that repeated reasoning and doing some analysis of it. And then question number 2, that integral point 0, 1. It is such an important idea here. Why is it they all go through 0, 1? And we start to develop that idea as well. And
on the part B to that question, would it be possible to have a point that doesn't pass through 0, 1? Why or why not? So they're really, it's deep thought. It's no longer just, I'm going to slide it back and forth real quick. It hasn't changed, so no, it's not. They really have to think further into it, and this is kind of forcing that issue.
Yes, when I get to that point, that's when I move towards something like a pair-share idea. Make them think about it first. Try and look at different ideas on their own beyond what's given on the page, and then start talking with each other and build it from an individual level up to a class level beyond then. So the next question, why is b raised to the x a horizontal line when b is 1? And they have to think through that. And again, I think a lot of the students thinking at that point would be trying ideas. What is 1 to the 2nd power? What is 1 to the 3rd power, the 4th power? If the students understand the exponential function, they'll know that the exponent is changing, and they need to look at different cases for that value of x. And then I love question 4, prediction. They have to start thinking on their own as to what's going to happen if we go between 0 and 1. What's going to happen when we raise 1/2 to a power, or any other fraction, of course, and what will it do to the graph? And they just got to start talking through it in groups, as pairs, whatever helps them get to that idea. This is an excellent activity that allows the teacher to not be the sage on the stage. It allows for driven learning.
Justify and predict, that justify and predict, justify and predict, explain. Those are now crucial for our students' success, because they really have to not just do the computation, but then explain how they arrived at their answer and why it's appropriate, and prove it. Usually when some kids hear the word prove, they think, you know, geometric proofs, but that's not necessarily what we're talking about anymore. The students have to be able to take all those numbers that are mushed up in their head and then take them out and put them into a verbal description. And I'll tell you, they get better and better at it when you allow them to step-by-step move through these types of documents.
Yeah, they don't like it at first.
No.
they really struggle with it. But once they get going on and they start to really see, they own their own understanding, it's very exciting. And then in the interest of time, start moving down through there. And as I want to show the bottom part of that, if we could, before we move on. As always, Texas Instruments likes to bring a formative assessment into it, and the bottom of this has a few of these. Do you understand what's going on? So this could be, again, your exit slip. It could be your next day activity. But what are these going to look like? Where is it going to intercept? You start off with 10 to the x, a basic one. Then you go 0.1 to the x. That's one of those screwballs that goes between 0 and 1. And then finally, what is 1 to the x going to look like? What part of this activity stuck? And that will help you get a good idea. And unlike the previous activity, this is a low-tech activity. It is pencil and paper. We use handheld as a teaching tool, but in this case, it's not a doing tool. It could be, but you could say, I mean, put your Inspires down. Let's see if you can do this on your own without using the Inspire. But it does a great job. And the last point I want to bring up is I like Texas Instruments because it does this with virtually all of the function families, linear functions, quadratic functions, exponential functions, whatever you need, those basic function families, they have an algebraic analysis of it. Some activity will take care of what you're looking for, and it will allow the students to own their understanding.
You could even chop this bottom portion right off the paper and give it to the students as a ticket out. And really start to stress things like interval notation versus set builder when we're talking about domain and range. And the second page of this TNS file, I know we only looked at the first one. The second one is where you're going to see differences in that base being between 0 and 1. So they do get the opportunity to see that as well and how that differs from a base larger than 1. So it's all there for them to play with, to explore.
And it will also either confirm or disprove their prediction in question number 4.
Absolutely.
All right, let's get to this composition activity. It's excellent.
This is an exciting one. Okay, so application of function composition. I was really excited to take a peek at this file because it is so real world that it's striking. There were some things in this lesson that I, as an Algebra 2 teacher, didn't even really think about using until I looked at this lesson and was like, oh, I should definitely make sure that I show this to my students. So it's really quite unique. So the lesson explores compositions of functions and their graphs by using real-world applications. In this case, we're going to be talking about the investigations in oil spill and how the oil spreads in water. The students are going to make connections between domain and range of the two functions that produce the composition function, and they're going to analyze data from a table and then summarize the relationship between the functions and their composite functions. I know that's a lot. I just said a whole lot of stuff real quick. Basically, what we're asking students to do is look at a real-world problem, look at real-world data, and analyze it. Now, this lesson specifically, I think that I would work with my students kind of in a chunking nature. I would probably do a couple of pages on the TNS file and the calculator file, and then I would stop and talk with the class as a whole. Then move on to a few more, stop and talk, because the connections that the students are making are not simple connections. They're quite in depth, so it's really important that you kind of go through this at a slower rate. So the lesson begins by looking at the graphs of x squared and x minus 3, and then looking at the composition of those two functions as x minus 3 squared. Okay, so you're looking at the two original functions and then the graph of the composition. They do this a few times with one linear and then a nonlinear. What the students are supposed to be grasping from this, what the students are supposed to be grasping from this is that the range of the inside function determines the domain of the outside function. That's the point of the graphing. I don't know that I would spend a ton of time on that aspect of the lesson. I think that piece of information right there, the range of the inside determines the domain of the outside, is going to help students finish the rest of this, go in depth for the rest of the question. So I know some of you saw this and you got excited because I did when I saw it too. This is an oil well, right? And then we see this little play button. So it has a purpose. What we're going to do is we're actually going to press this little play button and we're going to see something happen. Okay, so we see the oil spilling and we notice that it's spreading out, spreading out, spreading out, spreading out. Okay, so what we're doing as teachers now is we're stepping them through this and we're saying, okay, what's changing? What's staying the same, if there is anything staying the same, and how can we algebraically represent this spread? So when we go to 1.6, we see all of this data. So this is where we're going to kind of take a step back and we're going to take a look at the student document. I'm hoping this is the student one, that's the teacher one. Okay. The student document, and I would give my students the student document because it really does help us step through it. The first 1.2, this 1.3, this is all your graphing questions. We're going to skip right on over to 5, okay? So it tells us the information right here. One such application is the change of the area of a circular oil spill. Oil spill is spilling from a well at a rate of 2,500 gallons per day. At this rate, the radius of the circular pool of oil changes at a constant rate of 4 miles per day. Okay, so there's some really important information there. And I know that as we're going through these and the kids are taking their state assessments, it's basically become a reading test, has it not? So the students have to be able to read a set of information, figure out what the pertinent information is, pull it out in order to use it. So the first question says, okay, I want you to write an expression that represents the radius of the oil slick at time t, hour days after the leak has started. So now we're talking function notation here. We're not talking y equals. I want function notation. We're using variables t and r. And what do you already know about the radius? I know it's spreading 4 miles per day. Okay? So if the nice thing about this is we do have a teacher document to go along with us to make sure that we are exactly where we need to be, and I'll get you down there right here. Here it is, okay? So we've got RT equals 4T, so we've got our equation. We're asking what the domain is, what the range is, explaining our answers. There's that keyword again, explain it. Why is my domain this? Why is my range this? And then looking at, is the oil going to spread out forever? Is there a point where it's going to be no more? Those conversations are going to come up, which should be coming up. That's an incredible thing to talk about. So the next thing it wants us to do is it wants us to write, and this is really important, to write an expression to represent the area in terms of the radius. This is where I thought my students would get stuck. They can come up with the area formula for a circle. For them to have to know that they have to do a composition with the equation that they just built, right, with their radius, and compose it into the area formula, this is where my students, personally, my students will get stuck, and we will have to stop, we'll have to step back, and we'll have to discuss that. I know, Matt, you said similarly with your students, it would be a sticking point. So this we talked about even in terms of related rates.
Absolutely.
We see this later on in calculus.
Yeah, I saw this question and I saw the animation, and I never would have thought, it's a simple idea, but I wouldn't have thought of the area in terms of time. And that goes back to a calculus idea, but in this case, we're talking simple composition of functions using stuff they already know. So, I mean, you can go back to first and second differences, for those of you that discuss it that way, and you're going straight toward quadratic regression. So there's a lot of good, rich discussion that can happen here.
Right. Okay, so the next page is going to be incredibly important, especially as we go further on into Common Core, those of you that are joining it as much as I am. We talk about data in a table, right? So when we look at this data, I got to find it, hold on. Here's my data. I've got 3 columns. I've got my time, I've got my radius, and I have my area. So students should now be able to look at this table and say, okay, time in the first column, then radius is 4 times that, and then area. So all of their formulas that they created are coming as a numerical representation or a tabular representation on one screen here for them to see. And that's really powerful. So now taking that data and saying, okay, what can I do with it? I know that it's crazy looking, I know it is, but what can I now do with this? We talk about radius versus time, right? So I want to actually take this and see what will this look like if I were to graph this. If I'm talking about the radius, my radius versus time, what kind of function was that I created? So in our math teacher heads, I can hear you all screaming at me, it's linear, it's linear. Okay, so how can the students test that to see that it is indeed linear? So what they're going to do is they're going to come in and they're going to click to add their variables. And at the bottom, they're going to say it's time, I love when the little dots move. They get such a kick out of it. And then we are going to go to radius, and if we are lucky, we'll see a nice linear function, which we do, and that's 4t, right? We see our beautiful linear time versus, or radius versus time scatter plot. And if I hover over a data point, look what pops up. 1144, right? So I see all of those data values right on one screen, which is fabulous. We're going to do the same exact thing for our next one. We're going to have our crazy, all of our information in one spot here. We need to click here at our variable. Again, we're talking time. And in this case, we're going to talk about area. Now, the kids should know, okay, my area formula had a squared in it, which probably means my function should be quadratic. Okay, so we get a really nice graphical representation of that tabular data that we saw just 2 pages ago. And I think that's really powerful, that now that they can see this is over time how much the oil is spreading, the area over which the oil is spreading. And that's a really powerful tool, because then they start thinking, well, Mrs. Cucci, what happens when it goes off the screen? Well, you tell me, kids. Is it going to stop? What's going to happen to that oil? How far is it going to spread? What is the domain? What is the range? Let's talk about that. And it's a really powerful tool. For them to be able to see it with that little animation and then see it tabular and then see it graphical is incredibly important.
And during the BP oil spill in the Gulf, this was an incredible activity.
Mm-hmm.
Because that was approximately the rate it was spreading.
Right. This is just another representation of that. It just further explores the concept of how the area of the circular pool of oil is a function of the radius. So what the kids do, as soon as they see these open circles, they know to grab and pull. So they're going to actually take those, and we're going to see how they affect each other graphically. Okay, so we see the connection between the two. So no longer do we think that they're just 2 completely separate functions. We see how they interact with each other. It really drives home the concept of composition, what a composition actually means.
I'd like to go back to what Audrey said earlier, that the first part of this activity, talking about where do we get our domain for the area, it has to come from the range of the first function. I don't know how much time is actually needed for those first parts where they're graphing. When you come to this last part, it becomes so clear that one directly drives the other.
So if you're looking for a nice application piece for a composition of functions, this is a really great one, and I really do believe that it gives the students a deeper understanding of what composition means. Instead of just saying, well, G goes into F, F goes into G, we can actually see the mathematics behind a composition for real-world applications. So this is, I really have to say, my hat is off to whoever created it. They did a fabulous job, and I will be using it in my classroom soon as well.
Yeah, and paying attention to the chat window, up above several places, people were getting confused as to how to do things. And I just want to make sure that it's seen by everybody or heard by everybody. Make sure to check out those Atomic Learning sites, the sites listed in the chat window. And always remember that this stuff that we're doing, we didn't do. All we're doing is following the instructions that TI gives. They're very good at helping you with the tech tips to make sure you know what buttons to push, and also the good questions, the rich context questions that you can get out of these activities.
Yeah, so the tech tips are here. There's a tech tip right here, pause animation. So with these teacher documents, there's tech tips everywhere. So if you're not sure how to do something, even if it's grabbing something, tech tips are distributed all through these teacher documents. Also, if, I just lost my train of thought. Oh, a lot of times the things that people are asking, like how do I saw somebody asked about inserting a slider. It's a great tool, it's a great thing to be able to do, but also keep in mind that these Math Nspired lessons are created for us to steal. We're stealing them. They're there for you to use for free, and that stuff is already created for you. So I'm a firm believer in don't reinvent the wheel. It's there for a reason. Go and take it. You can take just one page and use it for your own and modify it and change things. They're already built in there for you, which thank you, thank you, thank you, thank you, because that saves me a ton of time.
All right,
Okay.
that, I believe, gets us to the end of our section. Steve, are you ready to help wrap some of this up?
Mike's ready. Mike, I'm sending it back over.
Thanks, Audrey. So yeah, I looked through the chat window tonight, and there was a lot of really excellent comments. I do want to mention where you'll get some more information from our website, because I think that sounds like that might be a need. So I'm just going to duck over to our website, which is education.ti.com. There we go. If you check out the Professional Development tab, slide down to Online Learning. There's some really great information here. On the left-hand side, we have live webinars. So we have some upcoming webinars. This is actually the first webinar of our spring series. So we have, I believe, 14 more webinars that focus on different pieces of technology or different concepts. So please feel free to check out those upcoming webinars, see which may interest you, and register for those, because they're all free and open for registration. Also, I think mentioned at least once or twice was that we have some on-demand webinars. So if you're looking to learn more, and I saw a few people were mentioning they sort of go through those. I think Stacy mentioned that. Feel free to check out those on-demand webinars. You can search for, again, particular content or technology and see what we've already done in the past and already covered. And then last but not least are the technology tutorials. And our friends over at Atomic Learning, if we click on Atomic Learning Tutorials, have created these really great short videos. So, you know, whether it's been a while and you forget how to do certain things, or you're brand new to Nspire, I think this is a great way to just begin introducing yourself to some of the capabilities. Currently it's broken down into basics and then the different applications. And again, you can see the videos are all pretty short, 3 minutes, 1 minute, 2 minutes. So you can rewatch them as needed and visit this page as often as you want. We did start some conversations tonight using Twitter, and we were using actually the hashtag T3TD. So if you have something to say, feel free to run to Twitter and post a tweet using that hashtag T3PD. We'd love to have you continue the conversation. To receive a certificate of attendance, go ahead and click that link in the chat window. It contains the name, date, and duration of tonight's event. Also listed there is a link for the documents. So the documents that Matt and Audrey used tonight are all there as well. Again, they can all be found on our website. But if you wanted one place for all the documents used tonight, that's where to go. In case you missed those two links for whatever reason, or they're not working for you tonight, have no fear. In a couple of days, you'll automatically receive a follow-up email from us that'll have a link to the recording, so you can watch this webinar again, but also a link to the certificate and the documents as well. Thank you so much, Matt and Audrey. I think you guys did a great job tonight of showing us some ways in which students, again, can handle and engage with algebraic reasoning. But also, I think, almost more impressed with just the comments that a lot of people have, some of the questions and the responses. I was really excited about that as well. So thank you so much both for the time that you took to get ready for tonight's webinar.
Glad to be here. It doesn't work without all the participants. I'm just thankful that they dove into it and had fun with us also.
Yeah, great job in the chat window tonight, guys. It's awesome.
When you leave the webinar, a brief survey will automatically appear in your browser. Your feedback guides us as we plan some of these future online events, and we really do appreciate your thoughts. If there are any skills or resources you'd like us to cover in a future webinar, please let us know. We definitely listen to your feedback, and we really hope you'll share your thoughts in the post-webinar survey. So again, thank you so much. Have a great night, and we hope to see you back online next week. Thanks again.
Good night, everyone.